Now, let's talk about the quantitative techniques. Okay. So we discussed four qualitative techniques. Okay. Then quantitative techniques, naive approach, moving average, exponential smoothing, trend projection, and linear regression. So these few techniques are known as time series models because the forecasts were done based on time for different time. But there are some situations where we forecast based on other scenarios, other factors also. So we'll discuss later. Okay. In case of time series forecasting, we set a set of evenly spaced numerical data are used, obtained by observing response variable at regular time. Say, for example, a normal shop owner, he collect his sales information, sales record daily. Okay, based on those sales record, he always uh, purchases items to replenish the inventory and satisfy the customer need. So the forecast based only on past events. Okay, no other variable or variables are important. Past, say the sales information of yesterday or sales information of last week, last month, or last year are used to predict tomorrow's demand or next week demand or next month's demand or next year's demand like this. Okay, assumes that factors influencing past and present will continue influence in the future. Okay, the factors which are influencing in the past will also influence in the future. So it is the assumption. So there are different components in case of time series, different components. We have to understand. The first one is trend. Sometimes we'll find a trend, but there are some seasonal variation. Okay. There are some cyclical variation, and there are some random variation in demand. Okay, it can be explained by this chart. Say this line is the actual demand of a product. So based on the historical information, these curves are generated, okay, or created. So the horizontal, this is a time in years, okay, for the last 4 years, the demand of a product or service is like this. Okay, it changes like this. So in this curve, we will find different components. As I mentioned earlier, there is a trend component. Okay, trend. The trend is a straight line, increasing straight line. Demand of electricity of a city or in a city increases like a straight line. Demand of uh, some commodity, okay, LPG, petrol, diesel, is like a trend. Okay. Then there are some seasonal variation and some, say for example, and demand of katas or stationary items increases at the beginning of the year when all the schools starts new academic year. Okay. So every year in the month of January, demand of this type of product increases. Okay, great. books or khatas or paper, pen, and this increases journals. And you may find also some demand of some items uh, vary with, say, for example, in Ramadan. Okay, demand of some items changes with temperature, weather temperature. Say in winter, the demand of um, sweater or jacket increases. These are some seasonal variation, right? Increases at different time of the season. There are some random variation also. So random variation, this is an unknown reason. Nobody knows the reason of this. Say, for example, the garment soul can block the road. Okay. So demand of an items decreases because of this blockage, like this. So this type of variation is unknown uh, in advance, known in advance. And there is a line. The line is average demand. So we find the components in proper forecasting uh, in this card. So if we know exactly how these components are affecting the demand, can easily forecast the future demand. Okay? Say the demand for dates increases significantly during the month of Ramadan. Okay, so those who knows about the nature will take necessary preparation in advance, right? So if the Ramadan or Ramjan starts in March, the business people will start to open their LCs for importing this type of products so that they can satisfy the demand in Ramjan. So these are seasonal variation. So the trend component, like a straight line, okay, it may increase like a straight line or it can decrease. Okay. The seasonal component, there are many different type of seasonal period, weekly, monthly, yearly. So in case of Eid, the uh, say for example, Friday is weekend. Okay, so in weekends, many people go to market to shop for the whole week. So demand for different items increases significantly in Friday. Okay, so every week there is a peak of demand in Friday, and the demand is at the lowest level in, say, for example, Thursday, like this, 7 days. So in month, there is a few weeks at the beginning of the month, the demand of commodities increases because people get their salaries. Okay, for a specific day in a month. Okay, for quarter, for different quarter in a year, different month in a year, or different week in a year. So there are different situations for seasonal components. So we have to understand the nature of the product, or the understand the seasonal variation of the respective product, and based on that, we have to uh, forecast the demand in future. So cyclical, as we mentioned earlier, seasonal cyclical variation. There are some random components impossible to predict in future in advance. Okay, erratic, unsystematic residual fluctuation. So due to random variation or unforeseen events, short duration and long representing. So it's very difficult to uh, represent the natures by any specific type. Now, the first techniques, as I mentioned earlier, there are different techniques of quantitative approaches. Okay, naive approach, moving averages, exponential smoothing, time projection, and linear regression. Okay, the first four are time series model, and the last one is associative model. The naive approach is the most simple uh, quantitative technique. Okay, assumes demand in the next period is the same as the demand in the most recent period. Okay, the demand of an item yesterday was maybe 100 unit. So tomorrow or today, the demand of that item will be 100 unit, like this. So from last immediate past information, we decide the demand in the future. Okay, sometimes cost effective and efficient. Normal shop owners sometimes follow this thing. Okay, the demand for, say, for example, eggs. And what was the demand yesterday? So the demand will be same today, and the shop owner will take the preparation like this. Can be good starting point. Okay, the not very significantly difficult. The second method is moving average. Okay, in case of IV approach, we use only one single data on only of the last period or immediate past period data is used in case of IV approach. But in case of moving average, we take the arithmetic means of several previous demands, of several previous historical demands. So used if little or no trend. So it can be very useful if there is no trend, because moving average is taking the average, okay, arithmetic mean. So if there is some trend, the arithmetic mean will give you wrong forecast. And say this is a trend. If we use moving average in such cases, we'll get the result like the average demand of it. And if we take the average demand, the future demand will be different from average demand, because there is a trend in the demand nature. Okay. So if the line is like this, stable, then we can use the naive approach. Okay. Now we can use the moving average. So moving average is demand in previous and period divided by n number of periods. Okay, this is the formula. Say here is an example. So demand of an item for different months from January to December is shown in this table. Okay. In January, the demand is 10, February demand is 12, and in March, the demand is 13.
Ndike,
So if
bejabole sili from parera nga murunda no.
this
Lisa nga murunda masoro murunda ka. I mean, I was for it criteria, but I'm no.
so in case of 3 months,
Guys,
what is speaking is mute your microphone. Okay. So
What?
3 month moving average. Okay, so moving average. Take the recent
Sorry.
past, recent past information. Say for example, in case of 3 month moving average, it can be 3 month moving average, it can be 4 month moving average, it can be 3 week moving average. So depending on the situation, what is your expectation type of moving average you want to use? So in case of 3 month moving average, you take the immediate past 3 months data. Okay, and then take the average. Say for example, demand for April, and these are the actual, these are the actual sales quantity. Okay, we want to forecast the demand in April. So demand for April is the arithmetic mean of this 10, 12, and 13. Okay, it is 11 to 13. Okay, we cannot go beyond this point if we do not know the demand of April. Okay. Now, if we want to forecast the demand for May, we will need immediate past 3 demand information. Okay, so to predict the demand of May by using 3 month moving average, you can calculate by using the last 3 data. Okay, these 3 are 12, 13, and 16. Okay, so you take the summation of these 3 and then divide by 3 for 3 month moving average. So it's 13 to that. Now, after the month of May ends, you get the actual data. Okay, this information you will get if the month is finished, the month is closed. Now, if you want to forecast the demand for June, you take again the immediate past 3. So that's why it's calling the moving average. You take the immediate past informations to calculate the average. Okay. So these are the forecasted value on the third column. And on the second column, these are the actual values. So if we have the actual values, we can forecast the future demand. If we do not have the actual values, we will not be able to forecast the future demand. Now, sometimes the moving average does not give better result when there is a trend in the nature. Okay, so moving average flatten the movement 10, 12, 13. So it take the arithmetic mean. That means it's at the middle of this 3 data. Okay, so if there is a trend, say for example, as we have shown, say if there is some trend, if you take the moving average, you will not get a good result or forecast if you use moving average when there is some trend. Okay, whether it's increasing or decreasing, you cannot. Moving average will not give good result. So in such cases, we want to be close to actual nature, actual demand of the item, to forecast. So if we give more importance to the immediate past than the older data, it will give us more accurate results. So in such cases, we use weighted moving average. Okay, everyone understand what is the moving average? The question may uh, appear in different forms. Okay, it may be 3 month, 3 year, 2 week, 3 week, 4 week. So you have to uh, change the equation accordingly. This is the equation, moving average, summation of the demand in a period divided by n. Okay. So if in the question you are asked to find the 2 month moving average, so you have to take the immediate past two. If you are asked to make forecast using 4 month moving average, you at least need 4 actual data to make 4 month moving average. Okay. And as I mentioned earlier, moving average will not predict properly in case of trends. Eh? We want to forecast perfectly for better result, for better business. So we use weighted moving average. And when there is some trend, we use this technique to perfect the forecast. So used when some trend might be present. Older data is usually less important, newer data and more importance. Okay. So we use different weights for different data. We give more weights to the recent data. We give less weight to previous or old data. So the equation we use in case of weighted moving average is weighted moving average is equal to summation of weight for period n into demand in period n weight by weight. So let's see an example. In this example, okay, the data is same as before the previous table. So we want to give more importance to the recent data, less importance to older data. Let's say, for example, you are asked to give weights like this 3, 2, 1. Okay, 3 for last month, 2 for 2 months ago, 1 for 3 months ago. Okay, so these are the three weights we are using with the data. Now the total weight is 6. So if you want to use 3 month moving average, you need 3 actual sales data and 3 weights that you have to use for giving importance. So this weight can be in terms of percentage. Say, for example, you want to give 50% weightage to the last month data or last week data or yesterday's data. You want to give 25% to 2 months data of 2 months ago. You want to give only 25% to the data of 3 months ago. Okay. So this is the way you have to use weights to give more importance to recent data and less important to older data. Okay. So moving average and weighted moving average is very important in forecasting, like the demand of different products and price of, say, stocks and in the share market, and price of commodities like gold, silver, etc. In the market, people use weighted moving average. Okay. And this is the calculation. So for example, we have 3 actual sales data, January, February, and March. In January, number of shares sold was 10. And in February, number of shares sold is 12. In March, number of shares sold at 30. Okay. Now we want to predict demand of April. Okay. The actual sales is not known in advance. So we will predict first, and after the end of April, we'll get the actual data. Okay. So the weights will be mentioned in question. The weights will be mentioned in terms of numbers. It may be in terms of percentage. It may be in terms of fraction on different ways. So it should be careful about using this equation. Okay. Now, to calculate the weighted moving average, 3 into 30. So 13 is the last immediate past month sales. Okay. We are forecasting the demand in April. So we give more importance to the demand of March, then January, and give February, then give the least amount of importance to the sales of January. Okay. So we give multiply 13 with 3, multiply 12 with 2, and multiply 10 with 1. Then divide the summation with the total number. Okay, 6. Now you will find that the demand will be closer to March. Okay, the last for actual demand. In this way, as you are giving more importance to the last one, the forecasted value will be close to the last one. Okay, bias to last one. But we are not ignoring the other data, historical data, and we are just giving less importance to older data. Okay. In this way, we can calculate all this forecasted values. You should keep in mind that you need the historical sales data for forecasting any future demands. Okay. So once the month is over, you get the actual demand, and then you can compare the actual and the forecasted. Okay, so actual is 16 in April, forecasted value is 12.12 by 6. After the month of May, we get the actual demand of May, and which is 19, and we get the actual forecasted demand of May is 41/3. So in case of May, we are using 16, 13, and 12, and giving more importance to 16 because we are giving multiplying 16 by 3. Then we are multiplying 13 with 2, and we are multiplying 12 with 2. Okay. So in this way, we forecasted the value of demand of the month of May. Now, once the month is over, we get the actual data, and then we can compare, okay, what was our forecast and what was the actual sales. So in this fashion, we can calculate the demands for different month of a year. Okay. Now the third one, potential problem with moving average. Increasing and smoothens the forecast, but makes it less sensitive to changes. Okay. So if we increase the number, say 3-month moving average, what will happen? It will flatten the number. If there is a trend, it will not uh, will not be it will not be available in the result. So it makes less sensitive to changes because we always try to forecast the future as perfect as possible. So if the technique is less sensitive to changes, it will give inferior results. Okay. Now, does not forecast trends well and requires extensive historical data. In such cases, we need historical data or historical data. And you see, we are using only the actual data to forecast future values. We are not using the forecasted value for forecasting the future amount because in forecasted value there is some gap between the actual and the forecast. So when we forecast demand for the month of May, we are ignoring the forecast we made for the month of April. And we see there is some gap between actual and forecasted figure. We are ignoring the difference. Okay, we are ignoring the difference between actual and forecasted values. So if there is any inherent problem with our model, it will be ignored. Okay, that's why we use another technique called exponential smoothing technique. Okay. So this graph shows the scenario between actual sales, weighted moving average, and moving average curves. This type of curves are used by different analysts to predict the future trends, change in trend, change. Say price of a stock is increasing, or demand of an item is increasing, then it becomes flat, then the demand or price is decreasing. So if we use the moving average gives us a delayed result, delayed. If we use 3-month moving average, it is delayed by 3 months. If we use 2-month moving average, it will be delayed by 2 months, right? From actual sales. But we can identify the change in trend by using moving averages. When this type of intersections are found, we becomes more confident about the change in trend. With the share traders or people in those areas use the moving average curves. More. Now, the exponential smoothing. In case of exponential smoothing, as I mentioned earlier, in case of moving average or weighted moving average, we need more historical data. But sometimes we may not have more data. If form of weighted moving average, exponential smoothing is a form of weighted moving average. When weights decline exponentially, most written data weighted most requires a smoothing constant. The term smoothing constant, term alpha of the smoothing constant is used in this case. So exponential smoothing techniques requires this smoothing constant value, and it ranges from 0 to 1 and subjectively chosen. It depends on different scenarios, different product, different environment. The value of alpha changes, and the value of alpha should be known or is required in advance for any specific. Say, for example, what is the value of alpha in case of uh, sales of computers or laptops in Bangladesh? So if we know the value of alpha from previous historical information, we can easily forecast in future. Okay, involves little record keeping of the past data. So exponential smoothing, the equation we use for exponential smoothing is this. Ft is the forecast, okay, for the period of t. Say for example, this is the month of November. We want to forecast the demand in December. So for December, let's say Ft or F12. Okay, the demand for next month. And if we know the demand for November, okay, which is Ft minus 1, T minus 1. So for example, in case of November, at the end of October, we know the demand of October and we know our forecast of October. Then from actual demand of October and from our forecast of October, we can predict the demand of November. Okay, so we need one actual data of immediate past period and one forecasted data. Okay, only two. No other data is required. Right? So Ft is equal to Ft minus 1 plus alpha into At minus 1 minus Ft minus 1. Right? Very important equation. You have to memorize this. Okay, so in case of alpha, which is known as the smoothing constant, varies from 0 to 1, as I mentioned earlier. And the value of alpha will be provided in examples or questions. Okay. Then At is the previous period's actual demand, so actual and forecasted demand. So in earlier techniques, moving average, we used only the actual demands, actual, to predict the futures. Okay. In case of exponential smoothing technique, we use actual as well as forecasted demand of previous period. Okay. So here is an example. Predicted demand is equal to 142 for Mustangs of previous period. Okay, so for example, demand of Ford Mustang in the month of October was 142. But at the end of the, which was predicted, forecasted demand. Okay. So at the end of October, we know the actual demand. So actual demand is 153. So we made some mistake in our forecast for the month of October because we forecasted 142 and we found it's actually 153. So there is a gap between these two. Now you are asked to assume the smoothing constant alpha is equal to 0.2. Okay, by using alpha is equal to 0.2, we can predict the demand for November. Say if it is demand for October, actual and forecasted demand, then it's for November. So 142 plus 0.2 into 153 minus 152. So the equation we used is Ft is equal to Ft minus 1 plus equal to At minus 1 minus Ft minus 1. So you see the new properties 142 and the result is 144 hours. vector. Okay. So how it affects our load text. In case of moving average, we require more data, say 3 month moving average, 4 month moving average. In case of exponential smoothing, it always requires only two data. Okay. So immediate past. In case of moving average, we use only the actual tumors. In case of exponential smoothing, we use forecasted demand as well as actual tumors. Okay. So if there is any mistake in the model regarding the uh, forecasting technique, we are addressing this by using both of the forecasted demand and actual demand. Okay. So this is the exponential smoothing technique. So effect of smoothing constant. What happens if we change the value of alpha gradually from 0.05 to 0.5? Normally smoothing constant generally 0.05 to, we can, it can vary from 0 to 1, but normally it's also between 0.05 to 0.5. It depends on the situation, it depends on the product. Okay, it depends on the market. So you will be provided the value of alpha. Okay, for calculation, we cannot just randomly choose any value of alpha. Okay. So as alpha increases, older values become less significant. Okay. So if we think the impact of the most recent data is more significant, then we can increase the value of alpha. If we decrease the value of alpha, it will decrease the significance of the most recent data. Okay, from the equation. Say alpha is multiplied. This is the forecasted value. Then actual minus forecast. Okay, then multiplied by alpha difference. This is the difference between actual and forecasted value. And if you increase the value of alpha, what will happen? The impact of this part will increase. Okay. So that is the impact of different values of alpha. So the blue line is the actual demand. The green line is the forecasted demand when you choose alpha equal to 0.5. And if you reduce the value of alpha, it reduces the impact of recent values. So increase in alpha, older values become less significant, less significant. Okay. This is the choose high value of alpha when underlying average is likely to change. Okay. So choose low values of alpha when underlying average is stable. So if the situation is stable, so you should prefer value of alpha lower. If situation is fluctuating, okay, then you have to, if the situation is fluctuating, you have to use higher values of alpha. Anyway, in questions, normally the value of alpha is provided, or you will be asked to pay necessary for reasonability of the problem. So the objective is to obtain the most accurate forecast, no matter what the technique is, right? So we want to increase the correctness of the forecast. So we generally do this by selecting the model that gives us the lowest forecasting error. So we have to check which technique gives the lowest errors. Which techniques. So to find the best technique, we have to calculate the forecasting errors. Right, we have to calculate the forecasting error and compare different techniques, how they differ by using forecasting error. And forecasting error is actual minus forecasted value. Okay. So actual demand minus forecasted value. That means AT minus FT. And there are different techniques. Okay. One measure of error. How to measure the error, forecasting error. There are different techniques. The first one is mean absolute deviation. Yes.
স্যার এই টপিকটা নেক্সট দিন করি, অনেকক্ষণ তো ক্লাস করলাম।
স্যার অলরেডি 1 ঘন্টা 47 মিনিট হয়ে গেছে।
তাই?
জি স্যার, আজকের মতো স্যার ফিক্স করলে ভালো হয়।
Okay, fine. So tomorrow we'll start at 6, right? Here. What about the plan for tomorrow? Is it 6 or 6:30? So let me know by message. So I'm going to conclude this and complete this topic tomorrow. And there will be an exam on this topic next Thursday, inshallah. Okay, if there is no other issue. Okay, thank you very much. Assalamu alaikum.